To solve an absolute value inequality analytically, the first thing we want to do is add 3 to both sides so that we can isolate the absolute value part. When we do this, we will get the absolute value of x plus 1 is less than or equal to 7. Now this is the part where we're going to split up the absolute value inequality into 2 compound inequalities. In order to understand the connector word in between the compound inequalities, we pay attention to the direction the inequality symbol is facing with regards to the absolute value, and the fact that we have a positive number on the right side of the inequality symbol. Because we have an absolute value that's less than or equal to a positive number, this will give us the intersection case. And when we have an intersection case, the connector word in between the 2 inequalities for the compound inequality is the word and. So when we split the absolute value up into 2 inequalities, the first case we will drop the absolute value bars and the direction of the inequality will remain the same. The second case, we also drop the absolute value bars, but this time we reverse the direction of the inequality symbol and take the opposite of 7. So just to point out one more time, this is the case where we must modify the original inequality. To solve the compound inequality, we first solve each individual inequality separately. I'm going to subtract 1 from the first inequality on both sides. So this will lead us with x is less than or equal to 6. I'm going to keep the connector word to remind me that this is an intersection case, and I will also subtract 1 from both sides of the other inequality, which leaves me with x is greater than or equal to -8. In order to determine the solution to this compound inequality, the first thing we would want to do is graph both inequalities on the same number line, so that we can see each inequality separately. I'm going to graph x is less than or equal to 6 in blue. So we're going to mark approximately where 6 could be on the number line. And when we graph x is less than or equal to 6, we are looking for all numbers that are smaller than or equal to 6. So we're going to shade to the left of 6. And because we have a less than or equal to inequality symbol, we will use brackets. Now to graph x is greater than or equal to -8, I'll use red to demonstrate the difference. And if we're going to graph -8 in relation to 6, -8 is to the right of 6 because it's smaller. And if we're looking at x is greater than or equal to -8, we're going to shade all numbers to the right of -8. And because we have a greater than or equal to symbol, we're going to have brackets opening up to where we shade. Now, this is not the complete solution of the graph. It's actually the union of the two. We want to pay attention to the connector word. And means take the intersection of the two graphs. So You can now see, because we drew the graphs in two different colors, we can see that the overlap is approximately in between the numbers -8 and 6. So I want to modify this so I can demonstrate my actual solution. Make it a little cleaner. So the final solution will look like all of the numbers in between -8 and +6, including the -8 and +6. If you want to write this final solution in interval notation, we will start off with a bracket, then a -8, separated with a comma with the 6, and end with the bracket. And this is the way we solve an absolute value inequality analytically.